all we need to do. Sometimes we get lump sum payments. We get a single payment. Might be one big payoff. You sell your property or something. Sometimes we get annuities. You win the lottery and you have the choice of taking the lump sum payment or the $350,000 every year for 20 years. Which one is better? You need these equations to determine that. But that it's as simple as that. We need to evaluate investments in the same year. Okay, so I've mentioned lump sum and series, and you can actually take the equations that I gave you and make a tree or a chart, I guess. So we have lump sum. Lump sum payments. Now, if you go forward, if you want to move values forward through time, so that means you're going to make an investment today and it's going to mature and you want to know what it's worth in 10 years, or somebody made an investment for you 5 years ago and you want to know what its value later in the future, then you do simple compounding. So basically, you want to know Vn, which equals V0, the value today, 1 plus I to the n. And you have all these equations. But basically, you want to calculate the future value, so value in year n, whatever, maybe 10 years from now. You take the amount that was invested today, and you multiply it 1 plus I, so maybe 5%, 1.05, and you raise that to the power of 10 years. You're going forward 10 years. Relatively simple. Most of what we do in economics is discounting, because we're estimating values in the future. We want to know what the dam is going to be worth, or the minerals, or the trees, or whatever. So we take those values, we move them back through time. So if you're going backwards, then you do simple discounting. So now I'm calculating V0, not Vn. So V0 equals Vn times 1 plus I to the minus n. It's the only difference. So what this will do is take some value, Vn, and move it backwards through time. The top one takes some value today, V0, and moves it forwards to calculate Vn. Any questions? It's really not that bad. You've probably done this before if you're in business already, right? Should I just skip all this then? No. Okay. For those of you who are sick of listening, just leave. Okay. And do you get this convenient tree form in your other class?
I mean, you tried 675.
Oh, okay.
It's very similar.
Oh, so you're taking the same stuff here?
Yeah.
Oh, bonus. Okay, so lump sum, the other way you can do it is a series of equal payments. This is key. So the series can be one of two things. It can be annual, where you get the payment every year. So if it's annual, then you ask two questions. Does it go forever or does it end? So if it goes forever, it is going to be, let's see if I can remember these. V0 equals A over I, and A is the annuity payment. So this would look like this, to infinity. So A, and you get some value. If it doesn't go forever, it's terminable. B0 equals A, okay, A over I times 1 minus 1 plus I to the n. Negative n. Okay, so A is going to be the payment. N equals the length of the series. I think those are the only new terms.
Which one's an L?
An L? This is
N,
A over
never
I.
mind. Never mind. Okay, I thought you were saying L.
Sorry.
N.
Okay, so we've got forwards and backwards. These are all backwards, by the way. Once you condense everything into one value, it's easy to move it forwards or backwards. So we've got annual payments, and then we've got periodic payments. And the same thing, do they go forever, or are they terminable? So an infinite periodic series versus a terminable. That's right. Okay, so this one is the terminable one. B0 equals A times 1 minus 1 plus I to the minus n, divided, the whole thing divided by 1 plus I to the t minus 1. So now we've introduced a new term, t. So t is the time between payments. Okay. I think I don't have the other one. Oh, maybe I do, maybe I do. Nope. Let's put a negative number in. Okay, I forgot to write down the other one, so you have to look it up. Similar though. The only difference is it goes forever. So what you have on the performance assessment task is some numbers. You will have V0, N, I. What you have to do is select the correct formula and just calculate the present value. This gives you some practice with that. So do you want me to do some examples, or are you comfortable with that?
I forgot how we should calculate here the minus.
Oh, the minus signs? You just punch in the negative on your computer. You'll have a, we can talk about that after. It's basically a lesson on how to use your computer. So the whole point of this is, who cares? Like, why do we care about this? Once we have these values calculated, you need to know what to do with them and what they mean. And that's more of the interesting part.